2015, paper 2, question 3, the line. So in question 3a here, we're given the coordinates of 2 points are A and B, and we have a line that is perpendicular to AB, and we want to find the value of t based on that knowledge. So if we do a little sketch to show us what this looks like, it can be any rough sketch, or you can actually sketch the line L1 properly. So what our sketch does is just gives us an idea of how we can approach the question. So here we have our point A, which is 4 minus 1, and we have a line perpendicular to 3x minus 4y minus 12 equals 0. So this point B, 7t, must be somewhere along that perpendicular line. But of course, if we have the line and we have a line perpendicular to it, then in order for us to figure out what t is, we need to remember that if two lines are perpendicular, then their slopes multiplied to give us minus 1. So if we look at the line, first of all, 3x minus 4y minus 12 equals 0, then I can rearrange that to get y equals mx plus c. And therefore the coefficient of x when the coefficient of y is 1 will be our slope. But this has to be 1y, so you must divide across by the number in front of y if we're going to do that. Or you can say a is 3, b is minus 4, and c is minus 12. And the slope then will be minus a over b. So either way will get you your slope. So in other words, m must be minus 3 over minus 4. So we end up with 3 over 4 for our slope. So that's the slope of the line. So if we get the slope of the points AB, well, A is 4 minus 1, B is 7t. So we have x1, y1, x2, y2. And our slope, again, page 18 in our maths tables, will allow us to get the slope of the line AB. So I'll just call that one M1, we'll call this one M2. So we have Y2 minus Y1 over X2 minus X1 gives us T plus 1 over 3. So now we have our two slopes, and we know because they're perpendicular that their slopes multiplied to give us minus 1. So if I take M1, we have 3 over 4, and M2 is T plus 1 over 3, and that has to multiply to give us minus 1. So multiplying out the top line there, we have 3T plus 3 over 4 times 3, which is 12, equals minus 1. And multiplying both sides across by 12 gives us 3T plus 3 is equal to minus 12. Therefore, 3T equals minus 15. And t is equal to minus 5. So again, simple little sketch reminds us that two lines that are perpendicular will give us our slopes multiplying to give us minus 1. So 10 marks were going for that question, and it was broken down into 2, 5, 8 or 10. So B wants us to find the distance between the point P and L1. So it's still the same line. So if we go back here, that line. So because it's looking for the distance between the point and the line, it has to be the perpendicular distance. So again, it can just be a rough sketch. We don't know where this coordinate is going to be. We know it's going to be 10 something. But we do know that it'll be the perpendicular distance that we're looking for. So we have the line was 3x minus 4y minus 12 equals 0. And P is the point that we're getting the perpendicular distance to. So that's going to be our x1 and our y1. And our perpendicular distance formula is A times x1, B times y1 plus C all over the square root of A squared plus B squared. And again, found on page 18 in our maths tables. So therefore, if I'm looking at the line, A must be 3, B must be -4, and C must be -12. So all I need to do is sub in the values into the equation. So we have A is 3 times x1, B is -4 times y1 plus C, and that's all over the square root of A squared plus B squared. So if we simplify the top line there, we end up with 30 minus 4k minus 12 all over the square root of 9 and 16. So therefore that's going to be 18 minus 4k. And again, we have our modulus sign there because it's always going to be the absolute value. Can't have negative distance. And of course we have the square root of 25, which is 5. So we were asked to get the perpendicular distance. So we were asked to get the distance, I should say, from P to L1. But of course, you can have an infinite amount of distances, so it's always going to be assumed that it's the perpendicular distance you're looking for there. So therefore, we have 10 marks going for that, and it was 10C, so 0, 4, 8, and 10. So in C, we have P is on a bisector of the angles, and it's between the two lines L1 and L2. And we have to find the possible values of K. So that means there's going to be more than one answer. So if we were to have a look at the sketch of our lines, we're going to have something like this, where we have two lines. We have the bisector, which means it's dividing those two angles. They're going to be equal. I'm cutting them in half. And P lies somewhere along this bisector line, and their perpendicular distance has to be the same. So in other words, from P to each line is equidistant. So that's going to be equal in distance. So that would be our perpendicular distance and our perpendicular distance. And we have L1 and L2. Where L1 was 3x minus 4y minus 12 equals 0, and L2 was 5x plus 12y minus 20 equals 0. So we've already worked out the perpendicular distance from P to L1, and we saw that that perpendicular distance was equal to 18 minus 4k all over 5. So therefore, if we're writing down the perpendicular distance for the second line, A is 5, B is 12, and C is minus 20. And the point P, this point here, we said was 10k. So that's our x1 and our y1. So if we're putting that into, again, our perpendicular distance formula, we have A times x1 plus B times y1 plus C all over the square root of A squared plus B squared. So again, if I simplify the top line there, we end up with 50 plus 12k minus 20 all over the square root of 25 plus 144. So our perpendicular distance from P to L2 simplifies down then to 30 plus 12k all over the square root of 169, which is 13. So of course these two perpendicular distances have to be the same. So what we're going to do next then is equate and solve, which will give us our two values. So we're going to equate 1 and 2 because they're equidistant. So that's 18 minus 4k all over 5 is equal to 30 plus 12k all over 13. So to get rid of our modulus signs, we're going to square both sides. So by squaring both sides, we're going to be very careful here that you're squaring the top and the bottom. So basically that gives us 18 minus 4k multiplied by itself. So 18 squared is 324. 18 by minus 4k, multiply them and double it, gives us 144k. And minus 4k squared is going to be plus 16k squared, all over 5 squared, which is 25. And then we have 30 plus 12k to be squared. So 30 by 30 is 900. 30 times 12k, multiply them and double it, gives us 720k. And 12k to be squared is 144k squared. And that's all over 13 squared, which is 169. So again, we want to simplify this, and we can see we're clearly going to get a quadratic. So I'm going to multiply across by 169. And then multiply across by 25. So cross multiplying here to get rid of our fractions. And I'm going to have to go on to the next page. So multiplying out our brackets there, so we're going to multiply 169 by 324 minus 144k plus 16k squared. And multiply 25 by 900 by 720k and by 144k squared. So what that gives us then is 54,000, lovely big numbers here in this question, minus 24,336k plus 2,704k squared is equal to 22,500 plus 18,000k plus 3,600k squared. So dividing across and simplifying, so we're bringing everything to one side. So we're going to go straight to the minus b formula here, just to make life a bit easier. So we have k is going to equal minus b plus or minus b squared minus 4ac all over 2a. And again, your minus b formula is page 20 in our maths tables. So if I sub in my values, we have minus 42,336 plus or minus the square root of 42,336 to be squared minus 4 times a times c all over 2a. And then subbing into your calculators and simplifying, so you're going to have plus or minus there. That gives us two values for k, 3/4 or minus 48. So it seems like a messy quadratic, ends up just being really easy when you're using your minus b formula. So then part 2 of the question says if k is greater than 0, find the distance from P to L. So k greater than 0 means it must be 3/4, because k is equal to minus 48 is negative. So if you ended up with your two values for k being wrong there, so both were positive or both was negative, you should still try and make some sort of an attempt to sub back in to work out your perpendicular distance, just to show that you knew what to do even if your values were wrong. So clearly if k is greater than 0, then that implies that k has to be equal to 3/4. So therefore our perpendicular distance is going to be 18 minus 4k, so 4 times 3/4 over 5. And again, you can sub it into either of your perpendicular distance, you'll get the same answer. So that gives us 18 minus 3 over 5. So therefore that means my perpendicular distance must be 15 divided by 5, which is 3. Now there was only 5 marks going for all of that, so part 1 and part 2. So it feels like a lot of work for just 5 marks. But again, that can vary from year to year in the marking scheme. So if it was answered badly, they give more marks to the first part than to the second part. So it might have originally been 10 marks and it wasn't answered well, so it ends up being bumped down to 5. Okay, so you can never judge what a question is worth from year to year, because it will always vary from year to year.